The transformation we are witnessing is not happening evenly across industries. It is not a single wave that hits all workers at once. Instead, it is a cascading sequence of disruptions, starting in digital work, expanding into knowledge work, and now beginning to reach the most stable parts of the professional economy. To understand where this is going, you have to look at where it has already begun to break. In the technology sector alone, hundreds of thousands of jobs have been eliminated globally since the rapid acceleration of artificial intelligence adoption. Companies such as Microsoft, Google, Amazon, Meta, and IBM have all gone through multiple rounds of layoffs in recent years. While executives often cite restructuring, efficiency, or macroeconomic conditions, a deeper pattern is emerging beneath the surface. A significant portion of these workforce reductions are happening at the same time these companies are investing billions into artificial intelligence infrastructure, new data centers, new AI model training clusters, new automation tools embedded into internal workflows. In many cases, the same companies reducing headcount are also publicly stating that AI will play a central role in their future operations. At Microsoft, leadership has openly emphasized that AI is now integrated across its product suite, from Office to Azure to developer tools. Internally, AI coding assistants are increasingly used to accelerate software development cycles. At Google, generative AI is now embedded into search, advertising systems, and productivity tools. Entire workflows that once required teams of analysts are being condensed into automated pipelines. At Amazon, warehouse automation and AI-driven logistics optimization continue to reduce the need for certain operational roles, while corporate teams are streamlined to focus on higher-level system management rather than manual coordination. What is important to understand is that these changes are not isolated decisions. They reflect a broader economic shift, a shift where labor is no longer the primary constraint on output. Intelligence, specifically artificial intelligence, has become a scalable resource. And when something becomes scalable, it changes its economic value. To see this more clearly, consider how AI is reshaping software engineering. For decades, software development was one of the most stable and high-paying career paths in the global economy. The demand for engineers consistently outpaced supply, and companies competed aggressively for technical talent. But with the rise of AI coding assistants, the structure of that labor market is changing. Tools can now generate boilerplate code in seconds. They can identify bugs, suggest optimizations, write documentation, and even build functional prototypes from natural language prompts. This does not eliminate the need for engineers, but it changes the ratio of engineers to output. One engineer with AI assistance can now accomplish what previously required multiple engineers working together. And this leads to a critical economic decision for companies. If productivity per worker increases significantly, companies do not always expand output proportionally. Instead, they often maintain output and reduce labor costs. This is why productivity revolutions often lead to workforce contraction in certain sectors, even as total economic output grows. We saw this in agriculture. We saw this in manufacturing. And now, we are seeing the early stages of it in knowledge work. But unlike previous transitions, this one is happening at a much faster pace. In agriculture, mechanization unfolded over decades. In manufacturing, automation took generations to fully mature. But in AI-driven industries, major changes are happening within a few product cycles. sometimes within months. This speed matters because labor markets do not adjust instantly. Workers cannot retrain overnight. Educational systems cannot redesign curricula quickly enough. And entire career pathways can begin to collapse before new ones fully emerge. One of the clearest examples of this disruption is in entry-level white-collar jobs. Historically, entry-level positions served a dual purpose. They were not just jobs, they were training grounds. Junior analysts learned how to interpret data. Junior writers learned how to structure content. Junior developers learned how to write production code. Junior legal assistants learned how to process documentation. But AI now performs many of these entry-level tasks at scale. This creates a structural gap. If fewer entry-level roles exist, fewer workers gain the foundational experience needed to advance into senior positions later in their careers. This is one of the most underestimated risks of AI-driven workforce transformation. Not just job loss, but pipeline disruption. Meanwhile, in customer service, the changes are even more visible. AI-powered systems are now handling millions of customer interactions daily across banking, retail, telecommunications, and travel industries. These systems can resolve billing issues, answer product questions, process returns, and troubleshoot technical problems. And they do so at a fraction of the cost of human labor. In many organizations, human customer service teams are now reserved only for edge cases, complex issues, escalations, or emotionally sensitive interactions. Everything else is increasingly automated. The result is a steady reduction in call center employment globally. Countries that built large service economies around outsourced customer support are now experiencing significant structural shifts as AI systems replace large portions of that work. India and the Philippines, for example, which have historically been major hubs for global call center employment, are now facing growing uncertainty about the long-term stability of those roles. This is not a sudden collapse. It is a gradual migration of tasks from humans to machines, and it is happening across multiple layers of the economy simultaneously. In finance, AI systems are now widely used for fraud detection, transaction monitoring, risk modeling, and customer onboarding. Tasks that once required teams of analysts are now handled by machine learning systems operating in real time. In journalism and media, AI tools are increasingly used to generate summaries, draft articles, and analyze large data sets. In marketing, AI can now generate entire campaigns, test variations, and optimize performance based on real-time feedback. In education, AI tutoring systems are beginning to supplement or replace parts of traditional instruction, offering personalized learning experiences at scale. In law, document review, once one of the most labor-intensive parts of legal work, is increasingly automated through AI systems capable of scanning thousands of pages in seconds. Each of these shifts may seem incremental in isolation, but together they represent a broad restructuring of cognitive labor. And at the center of this transformation is a fundamental economic reality. If intelligence becomes abundant, its market value changes. For centuries, human intelligence has been scarce. Not everyone can analyze complex systems, write effectively, or generate strategic insight. But AI systems are rapidly changing that distribution. They do not get tired. They do not require salaries. They can be duplicated instantly. And they improve continuously through scale. This creates a world where access to cognitive capability is no longer limited by education, geography, or experience in the same way it once was. And that democratization of capability sounds positive on the surface, but it also introduces new forms of competition. If everyone has access to powerful AI tools, then advantage shifts away from knowledge itself and toward how effectively that knowledge is applied. In other words, execution becomes more important than information. But even execution is becoming partially automated, which leads to a difficult question. What remains uniquely human in the labor market? The most common answer is creativity, empathy, and judgment. But even those domains are being influenced by AI systems. Creative tools can now generate art, music, video, and writing at scale. AI systems are being trained to detect emotional sentiment and respond appropriately in customer interactions. Decision support systems are being used in medical diagnostics, financial forecasting, and legal strategy. This does not mean humans are being fully replaced in these areas, but it does mean humans are increasingly working alongside machines that influence or accelerate their decisions, which raises an important shift in identity. Workers are no longer just performing tasks. They are supervising systems that perform tasks. And this changes the nature of expertise. Expertise becomes less about doing the work manually and more about knowing how to direct systems that do the work. This transition is still in its early stages, but it is accelerating quickly. As AI models become more capable, they are being integrated deeper into enterprise systems, not just as tools on the side, but as core infrastructure. And when a technology becomes infrastructure, it stops being optional. It becomes the environment in which all work takes place. That is the direction we are moving toward. A world where AI is not a separate tool you choose to use, but a foundational layer embedded into every workflow. And in that world, the definition of productivity changes again, because productivity is no longer just human output. It becomes human plus machine output. And that makes comparison to the past increasingly difficult. A single worker in 2026 may produce far more output than a worker in 2006. But that does not automatically translate into more jobs, because output and employment are no longer directly linked in the same way. This is why economists are divided on the long-term impact of AI. Some argue it will create massive new industries and entirely new job categories that we cannot yet imagine. Others argue that the speed and scope of automation will outpace the creation of new roles, leading to long-term structural unemployment or underemployment in certain sectors. Historically, technological revolutions have tended to create more jobs than they destroy over long time horizons. But the transition periods have often been painful, uneven, and socially disruptive. And the AI transition may compress that pain into a shorter time frame. Because unlike previous revolutions, AI does not require physical infrastructure to scale. It scales through software deployment, instantly, globally, at near zero marginal cost. That is what makes this moment different. Not just that machines are becoming more capable, but that capability is spreading faster than any labor system can realistically adapt. We are now entering a phase where companies must decide how to structure their workforce around systems that are improving continuously. And workers must decide how to remain relevant in a system where the baseline for competence is constantly rising. The future of work is not a distant concept anymore. It is a present-day negotiation between human labor and machine intelligence, and that negotiation is still far from settled. What is clear, however, is that the workforce of the future will not look like the workforce of the past. It will be smaller in some areas, larger in others, more technical in some roles, more abstract in others. But above all, it will be defined by collaboration between humans and artificial intelligence at every level of the economy. And whether that collaboration becomes a story of empowerment or displacement will depend not just on technology itself, but on how quickly society adapts to the reality that the nature of work has already changed, and it will never return to what it once was, because the replacement is not coming. It is already here.